right, so we're starting our toxicology notes today. Current slide, here we go. All right, so toxicology, poisons, drugs. How do we test for them? That's pretty much it. How do you test for these drugs to tell if someone was killed with one of these things? So is the study of poisons, toxicology. Toxicologists study the harmful effects these substances may have on the body. So how do they affect the body? How could they cause sickness or death? Forensic toxicology is the science of detecting and identifying drugs and poisons a person may have used for the medicinal, recreational, or criminal purposes. Either way, whatever caused their demise, just trying to determine how can we test that in a person's deceased body. So 3 primary responsibilities. Try to move me up here. Here we go. Is post-mortem drug testing. So we have a person that is deceased. We don't see any physical reason why they should be dead. Maybe they're not old. There is no wounds. There is no, underlying factors. It doesn't look like they've had a heart attack. So all those things are not there. So you're like, okay, so how did this person die? Did they eat something? Did they ingest something? Is there a poison? Was there an overdose? Post-mortem drug testing. So accidental poisonings, drug abuse cases, suicidal poisonings, or homicide. Either way, just trying to detect those poisons or drugs in their system. Workplace drug testing. Okay, so that's a huge part of a toxicologist's possible job is there's tons of jobs that require drug testing to be done. So that'd be a pretty common thing to have to run is running people's drug tests for the court system as well as like lots of jobs. So that'd be a big part of it is just testing it to see if they have drugs. It's a very simple test generally. So even though the schooling could be a little bit longer for a toxicologist to understand the chemistry of things, the actual testing themselves are pretty simple tests to see if someone had that drug in the system. And the identification of contraband material. So if you're finding things that are illegal. So if there's a drug bust, well, what drug was it? Just because it looks like, oh, this looks like cocaine. They're not just going to say yep, it looks like cocaine is cocaine. No, they're going to send it off to a lab and have it tested to see what it is. So exposure to the toxins can happen in 4 ways. So ingesting, so them through eating. Okay, so you can obviously eat the poison. Inhale, so you're smoking something, inhaling something. Even an inhaler, if taken enough, is a poison. Injecting, okay, so injecting it straight into their bloodstream. Poison, heroin, those kind of things. Absorbing through the skin. So some goes directly through your skin, like radiation poisoning. That's still poisoning, just goes straight through your skin. So toxic substances can be classified by how people are exposed to them. So intentionally, we can say they intentionally took this to treat an illness or relieve pain. Maybe they took too much. Maybe they accidentally mixed it with alcohol when they weren't supposed to. Accidentally by overdose or harmful combination. So same thing. So they intentionally to treat their illness or relieve their pain, took these pills. They accidentally took too much. So intentionally, I mean, they take those medicines and just for whatever reason did something weird. Accidentally by overdose or harmful combination. So it truly was an accident. They didn't mean to do it, or deliberate as a suicide attempt or to inflict harm or death upon others. So they were purposely murdered, or they purposely took a whole bunch of pills and a whole bunch of alcohol to kill themselves. Toxicity, so the extent that something is toxic, how do we judge how toxic something is? How poisonous is affected by many factors. For one, dose, how much was taken. So basically anything you can think of is technically a poison if you take enough of it. Even water, if you take enough of it all at once, would kill you. So everything has to be in moderation. So prescription drugs that your doctor gives you because of something that you need is prescribed, and taking that one thing could help your body, but taking the whole bottle would kill you. So dosage definitely matters. Duration, so frequency and length of exposure. Being exposed to, like an x-ray because you broke your wrist, not going to be that big of a deal if you have one x-ray. Being constantly exposed to radiation because you work in a radiation facility before we knew all the issues with it, and then you get, cancer later in life because you had radiation poisoning. Duration, how long were you around that substance? Were you by it for a second, for a day, for an hour, for weeks and weeks, months and months on end? How it was taken, ingested, inhaled, injected, or absorbed. So lots of drugs, it matters how it was taken, if it's a poison or not. So for example, the most poisonous substance on the planet is botulinum toxin, which is the stuff they use in Botox, botulinum toxin. But if you just breathe it, it's not that it's not bad at all, but it's not generally going to be fatal. It's really only going to be fatal if it's ingested. So it matters how the drug is actually taken. And the interactions, what does it interact with? Lots of overdoses or killings happened because they mixed two things together, not because of that drug by itself. There's definitely been a huge history of poisons. I would say it's one of like the oldest on record things that we have for murder is killing people with poison. So poisons have been around, documented since 399 BC. The Greek philosopher, why can't I say this word now? Philosopher Socrates was one of their first victims they have on record. Socrates is found guilty of corrupting the youth of Athens and was sentenced to death by poison, by hemlock. So they actually they gave him hemlock, and it was a really painful, awful way to die. Poisoning was very common in the 17th century as arsenic and cyanide were used to settle disputes. Like they were just like, I hate this guy. I'm going to put a little bit of cyanide in him, a little bit of arsenic in him. No one knew how to detect these poisons. The person wouldn't look that, it would just look like they died of natural causes, basically, before we could do all these tests. So people were poisoning people a lot back when that was then because it was just so easy. It was so easy to get away with. Arsenic is a chemical element that occurs naturally in the soil and minerals. It's released naturally from Earth's crust through erosion, runoff, volcanoes. It also can come from burning fossil fuels. Arsenic can contaminate the air. Why am I yawning so much? It's after school for me. Arsenic can contaminate air, water, and soil. I know there's some arsenic in some of our water supply, and you have to be careful about it. Arsenic is an odorless, tasteless poison, so that's why it's really the most used poison, because you can put it in things and it doesn't have an odor and it doesn't have a taste. So pretty easy to get away with. Not anymore. We've really developed tests for it because it's been used for so long. But back then, really big deal. Exposure to can cause many health problems. Being exposed to low levels for a long time can change the color of your skin. So you're seeing these little color spots here. Cause corns and small warts, stomach pain, nausea, vomiting, diarrhea, numbness in the hands and feet, partial paralysis, blindness, and a variety of cancers. So a lot of stuff. Exposure to high levels of arsenic can cause death. So if they give you a lot at once, you will die, but they can kind of give it to you slowly. So it also looks like you're just slowly getting sick. So then people really don't question it. They're like, oh, well, they've been sick for so long with something and then they died. So really common poison for back before we could test for it. Arsenic is found in some of our foods because, like I said, it's in our water supply, it's in our ground. So we do eat a little bit of arsenic in things that we ingest. So rice that it's grown with can have quite a bit. Beef, chicken, spinach, grape juice, shrimp, and fish. Got to be careful with fish that's around a lot of coal plants, because the burning of fossil fuels, it lands the arsenic in that water supply. So there are some lakes that specifically say you can't eat fish out of it because of the arsenic is so high. Mercury as well. Mercury can be high. So through much of the 19th century, a third of all criminal cases of poisoning involve arsenic. So it's been the most popular poison of all time. And then this guy, James, the Marsh test is a method that detected arsenic and was the first to use toxicology in a jury trial. So he fixed it for us. It's like missing a slide. Or am I just not seeing it? Oh, that's fine. All right, so James Marsh came up with that first test to start catching. Maybe it's after. Yes, it is. Okay, there we go. I got confused for a second with what we were at. Now, cyanide is the second most popular poison that's been used over time. So cyanide is rare but potentially deadly poison. It works by making the body unable to use life-sustaining oxygen. So basically, it stops you from being able to breathe. Cyanide sometimes is described as having a bitter almond smell, but that's it. It's just a slight bitter almond smell. So very light odor. Most people don't detect it. Cyanide enters water and soil or air as the result of natural processes and industrial activities. So there's lots of industrial things that we do that create it. Cyanide is contained in cigarette smoke, actually. And the combustion of products of synthetic materials such as plastics, so the burning of plastics, produces cyanide. A common source of cyanide poisoning is smoke inhalation. So a lot of times, if a person's in a burning house, the reason why a lot of times they will die is they'll die of smoke inhalation before they die of like the flames, because they're breathing cyanide, they're breathing a poison, because everything that's in the house that has any plastic, any rubber, any silk, which is a lot of things in a home, produces cyanide in the air, and they're breathing it. Now, one guy that I want you to remember, he's probably the only guy in this unit. Like every unit has a guy. The guy for toxicology is Matthew Orfilia. He's considered the father of forensic toxicology. He wasn't the first person to ever figure out how to test for arsenic, but he perfected it, and he worked on it really hard, and he was very popular in using it in cases to actually get people convicted. So kind of the first time we're really using it in court is with Matthew Orfilia, father of forensic toxicology. One of his very early cases that he's very well known for is getting Mary Lafarge in prison. It was a really big deal because she was young, she was pretty, she was a woman. We don't generally convict young, pretty women. She was pretty high up in society as well. And she was convicted of killing her husband with arsenic poisoning slowly. And she would have definitely got away with it. But this guy came in and had to pull up the body and had to figure out how to test a body that had been that decomposed, figured it out, and realized that his body was way too full of arsenic. So she had been slowly poisoning him. Today, forensic toxicologists are concerned with legal and medical aspects of alcohol, drugs, poisons, toxins, and body fluids, as well as alcohol. That's all a part of this. People tend to forget that it's a drug, but it's in the drug category. Toxicologists will often work with pathologists. So those are the people who do autopsies. So a lot of times they're kind of like working together, because the person who's doing autopsies, a pathologist, will send over samples to a toxicologist to run a tox screen to see what kind of toxins were in that person's body. So the body fluids, or possibly even chunks of their body, like pieces of liver, because the liver is what cleans out our body. So it's going to have drugs that were in it. They use highly sophisticated instruments, chemical reagents, and precise methodologies to determine the presence or absence of specific substances in a sample. They may also be responsible for presenting that evidence in court. Just like all the other jobs we've talked about, they're going to have to go to court and say, this is what I found, this is the levels I found, this is the normal levels in a body, and theirs is very high. So I have to explain how that poison is found in their body. Toxicologists also analyze evidence to determine if alcohol or drugs were a contributing factor in criminal cases, such as vehicular homicide. So like if you had a car crash, really bad car crash where someone died, was the person driving drunk? Was the person driving high? That changes the kind of case that they're dealing with, changes the sentencing. Sexual assault cases. So testing a girl who came to the hospital, thinks she's been a victim of sexual assault, taking her tox screen to see if she has been date rape drug. So that's a very common thing. We'll talk about the date rape drug a little more later. The field of forensic toxicology has also grown to include drug and alcohol testing for employers and schools. I mean, even y'all know athletes get tested all the time. So it's a pretty big field. There's definitely a lot of job security because we're always doing those testings. Almost last slide? Yes, last slide. So there are two types of poisoning. You can be acutely poisoned or chronically poisoned. So acute means involves a high dose over a short time period. So either all at once or like really close together, getting them really high doses because your goal is to kill them right now. Chronic poisoning involves a lower dose over longer periods. So like slowly killing yourself with alcohol, like becoming an alcoholic, slowly alcohol poisoning. Or someone like in that story with the wife, she slowly gave her husband arsenic, just a little at a time in his tea until it built up so much in his system that he died. People have mercury build up in their system, lead build up in their system, because we used to use lead in a lot of things. Mercury was in several things you could find in your home. So they'd have these symptoms that they were just casually touching throughout their life and eventually develop into a bigger poisoning problem in their body. Poisoning causes less than 0.5% of all homicides. Accidental drug overdoses are much more common. So out of all the cases that we see today, poisonings used to be a big deal, huge deal. Like everyone was poisoning everybody because it was hard to test for. Now, toxicology is one of the oldest fields in forensic science. So like the one we just talked about, DNA, that's like the newest. That's the newest thing we've done in forensic science. Toxicology is the oldest. So we are pretty good at it. We can test for pretty much everything at this point. And if we haven't learned how to test for it, we can learn how to test for it. So pretty good at catching people who die of poisonings. So, meaning, with that being said, people don't poison that much anymore because they know they're not going to get away with it. It's not a very good choice because we have such developed tests. So even though it used to be a bigger deal, these days it's much more likely to be dealing with cases of a drug overdose, trying to figure out, was it a forced drug overdose? Was it a accidental drug overdose? Was it a suicide overdose? Kind of looking at more. So you're going to be dealing more with drugs and alcohol than you would be for like arsenic and cyanide than what we used to. All righty.